right? Temida wants to distribute his application to wide audience. He is considering distributing it as an open source or proprietary software. Describe open source and proprietary software, right? Okay. Now, you know, open source is where you have now I will just list down the characteristics of open source software. You know, it's free. We call it free and open source, right? When it comes to free, that means there's no charge. No charge, because these people, they develop based on funds that they get. At the same time, free here means no restrictions. No or less restrictions, right? That's why it's called free. And then open source. Source is open, which means the source code is given, right? So you have access to source code, right? And because you have access to source code, now this is, see how we come up with the answer, right? Logically, step by step. Access to source code. Since you have access to source code, you can edit and share by improving the software. So it's like a community service, right? You edit it, you add more components, add more functionality, and then you share it with the community, right? And they continue this based on the funds that people give. Proprietary is owned. Is owned by an organization or an individual, right? Owned by a company or an individual. This often, right, has to be purchased. Not always, because there are freeware proprietary software which is free, right, free of charge, but usually you have to pay a fee. You have to purchase the license. Okay. Then the organization has the rights, right? The rights will be rights to copy and distribute, will be controlled by the company. Okay, so those are the differences between the two, right? Open source and proprietary. Okay, understood. Any questions, any doubts? Also, good morning.
No, sir.
Okay.
Good morning, sir.
You can download these screenshots. Semita also considers distributing a trial version of the application. Identify the type of software he could use to distribute his application as a trial version. What is it? What do you think? Trial version. What is the type of software that you can use to distribute it as a trial version? Trial version. You can even call it trial software. The proper term or the mostly used term is called shareware. Shareware, right? Or you can call it trial software also. You don't call it trialware or something, right? It's trial software or shareware. Shareware is the ideal name, right? Jamie to make sure that all data transmission to and from his website is secure. Underline the important parts here. One way a user can check if his website uses secure data transmission is to check the certificate. Give two other ways that user can identify his website uses secure data transmission. Well, you can check the URL. Don't just say HTTPS, right? Check the URL with HTTPS because HTTPS use um, SSL or TLS encryption protocol to encrypt the data before transferring. Okay. Then you can look for the padlock sign. Padlock sign should be locked. If they ask for more, you can write about third party security verifications, right? Examples, other companies, they come and check the security of this and then they endorse, right? Example, VeriSign. VeriSign is actually a company, right? Even GoDaddy, they also do that. So you will see that this something like this transaction is secured by VeriSign, something like that. Right? Understood? Uh, In a one human model, for a computer system, a central processing unit contains several different components. The table contains the name of the component or a description of their role in the fetch, decode, execute cycle. Complete the table with the missing components names and description. Memory address register. Now this was not there in the book, right? MAR. Was it there? Hello. Was it there in the book?
Sir, I don't remember seeing that.
Yeah, that's the thing. In the book, there was the current instruction register. Then there was the program
There was
counter
program counter. Yeah.
and the accumulator. No?
Yeah, the accumulator.
Yeah. So anyway, we'll write what this is. Also, right? Memory address register. Mm, yeah. This holds the address of the data instruction to be fetched or stored. Program counter, you know what it does, holds the address of the next instruction to be executed. Accumulator. Right. This is a register that is built into the arithmetic logic unit. It temporarily holds the result of the calculation. Right. So, like before and after processing, this data are held in the accumulator. Accumulator, as the name says, accumulator, it collects. Right. So this is the accumulator. You might see this as ACC also, right? Accumulator. Okay. This is the register that holds the data or instruction that has been fetched from the memory. Right. For this one, we have to use MDR, right? Memory data register. Actually, there are so many registers, right? They have given only 3 registers in the book. So these 2 are extra. Just know about these 2 as well, right? Memory data register. Control unit. It sends control signals to various internal parts of the computer to manage the execution of the instructions. You can read my handwriting, no?
Yes, I can read.
Oh, it's very ugly, but hope it's readable. This carries addresses around the CPU. Carries addresses, so it takes the addresses, transfers the addresses. So it has to be the address bus, right? Address bus. So we have the address bus, we have the control bus, and we have the data bus, right? Okay. Right, this one. A greenhouse uses a system to monitor the conditions that plants needs to grow. The status of each condition is given as true or false. Window open. Now, see, in this kind of a question, they should tell us the value that they're going to use for different state. That is this one. If this is not there, we cannot find any answer, like, or we cannot look at any scenario, right? Window open is represented with true or as 1. Temperature greater than or equal to 26 is represented as true. Humidity greater than or equal to 50% is represented as false. So this has to be given. It's a must, right? Okay, now based on that, we have to evaluate these scenarios or these logical expressions. Temperature greater than or equal to 26. Is it true or false? I think most of you got this right. Temperature greater than or equal to 26.
False.
True. False. Yeah. True, right? It's true, right? Temperature greater than or equal to 26. True, right? Why do you say false? See, temperature greater than or
Yes, sir, that is true.
okay, that is true.
I was saying that.
For a second, I thought whether my eyes are bad, vision is bad. Right. Then humidity greater than or equal to 50. That is, if humidity is greater than or equal to 50, we have set it to false. So this has
False.
to be false. Right. Now true and false joined with and, joined by and, the result is going to be what's the result? And operator works,
False.
False, yeah. The result will be true only if both conditions are true. So one is true, the other one is false, so the result is false. Window open. Window open is true. Temperature greater than or equal to 26 is true. Now it's joined by O. True or true. True or true. What does it evaluate to?
True.
That's like that's true, yes. In operator, even if both inputs are true, you get the result, right? Right. Window open is supposed to be true now, but it is not now. So not window open is going to be false, right? Okay, window open is true. Not window open is the opposite of that, or the negation, which is false. Now don't forget that there are brackets here, so we need to evaluate what's inside the brackets first. Temperature greater than 26 equal to 26 is true. Humidity greater than or equal to 50 is false, but it is not here, so it has to be true, right? Humidity greater than or equal to 50 is false, and we have negated it, which means it should be true. So now first we evaluate what is inside the brackets. True and true. True and true. The result is true and true. Both conditions are true. So the result is
True.
true. And now we take that true and this false and join by O. Join it O. So that is false or true. So what's the final result? False or true?
True.
True, because it's the operator, right? Others, if you don't understand, let me know. So false or true is true because it's the operator. Even if one input is true, the result is going to be true. Right, again, the brackets. Window open is true. Temperature greater than or equal to 26 is true. True or true is true. But here it's not, it's negated, right? So we get false here. Humidity greater than or equal to 50 is false, but it is not here. So it's going to be true. Okay. Right. Now, false and true joined by and. What's the result? False and true.
False.
False and true is false because it and both inputs have to be true. Okay. Understood? Easy, right?
Yes.
False, true, true, false. Yeah, correct. So since I have shared the paper, I would suggest you to do it again on your own, right? And then check with the answers that we discussed. Because they have sent us the your grades, your batch grades according to mark boundaries set by gateway, right? And according to them, this is just for school. For A level, we have subject grade boundaries. I don't know what they mean by that, right? According to edX, I mean the gateway grades. None of you has got 9, 8, 7, 6. None. Right? All of you have got 4, 3, 2, 1. And fail also, I think. But that's not the real grading, okay? According to last year, Edexcel grade, they had given 9 by 60, 63. But always we should keep our standards high, right? Because we don't know, like last year, the year before, there was pandemic, right? So this year they might increase the cutoff marks. So we had to be prepared, right? So always try to get at least, let's say, the paper is out of 80, no? At least 70 for both papers. Okay, to be on the safe side, get at least 70 for both papers. Okay, so work hard. These few weeks are more than enough, right? The inputs to the system. Okay, this one we had to create a logical expression, right? The inputs to the system are W, right? Window is open when it is 1. Again, these values are important, right? W is 1 when it is open. It is 0 when it is closed. So do a small analysis before you start. Temperature greater than or equal to 26 is represented with 1, and less than 26 is represented as 0. Humidity greater than or equal to 50 is represented as 1, and less than 50 is 0. The system will sound an alarm when certain conditions are detected. Alarm X will sound 1. So if alarm is on, it will be 1, right? It's represented as 1. Window is closed. Alarm will sound when the window is closed and temperature is greater than or equal to 26, or temperature is less than or equal to 26. Now that's wrong, no? Here they have checked greater than or equal to 26. Then they should be less than 26, right? Not equal, right? That's a mistake. And humidity greater than or equal to 50. Construct a Boolean expression with the letters W, T, and H. Okay, so what's the result? Result is going to be X. For this result to be true, what are the conditions we have to satisfy? Window should be closed. What is window closed? What is window closed? Look at the value. For window, we use W, but what is the value for window closed? Come on, speak. Yeah, it's 0. So if W is used, and if the value is 0, it has to be W. Okay, it has to be not W, right? Not W. You understand? Window is closed. For window, we use W. If window is closed, the value is 0. So we can't use W. We have to use not W, right? Because W is assigned with 1. If it is 0, it should be the opposite of W, which is not W. Okay? And then it is joined with and. Temperature greater than or equal to 26. What is the value? What is the value? Answer?
T.
Answer, what's the value? Temperature greater than or equal to 26. Is it 1 or 0? Answer? Vishal? What's the value? 1. Vishal? Is it 1? Vishal?
Yeah.
Yeah, it's 1, right? Temperature is greater than or equal to 26. Right? So it is 1. If it is 1, it has to be T, right? It's T. Now both these will be joined with O, right? Temperature less than 26. Temperature less than 26 is 0, which means it is not T. Okay, not T. And humidity greater than or equal to 50, that is 1, so it is H. Okay, that's how you write. Understand? Did you understand? Not W and T, O, not T and H. Yeah, correct. Okay, so if you write it in the other way, like remember last term we had a small issue, no? They had used this bar thing. So if you write it with bar, it will be like this, right? Not W will be W bar. So W bar can be written like this or this. That is also bar. Bar means not. Okay. So W bar end is represented as dot T. Okay. And then O. For O we use plus, right? And then not T. Not T means T bar and H. T bar and H. Right. That's the other method. Is that clear? The pseudocode includes several features that makes it easy to read and understand. Identify 3 of these features. Right. So what do you think? What are the features? Yeah. What are the features? Anyway, I can't hear. What? Can you increase mic volume? Couldn't hear.
Comment?
Comments. Oh, okay, right. Yeah. The use of comments, right? If you look at the variables, they make sense. Product, search, start, position, right? So the meaningful variables or sensible variable names. Names, or we also call them identifiers, right? Right. Then we can talk about the indentation. You can talk about indentation here because it's not the Python code, it's the pseudocode that they have given. So you can talk about the indentation, right? Right. What else? You can also talk about the white space. That's the blank lines, right? White space. And also the naming convention. If you look at the variable names, you can see that they have used the camel case, right? The naming convention of variables, right? Naming convention. Convention means the standard, right? Naming variable. Example, camel case. Camel case. Camel case. Okay. Right. Understood. A line number that contains a variable being incremented. A variable being incremented. Right. Tell me, a line number where a variable is incremented. What is the line number?
14.
14. Yes. Start position equals mid position plus 1. So that's plus 1 is the increment. Right. So 14. A type of loop structure. Most of you got this wrong. They're asking about the type of loop structure. Right. Well, it's bit misunderstanding. So most of you wrote repeat until. I think I gave marks for that, right? But they were expecting post condition loop, post condition, because repeat until is a post condition. Why is it called a post condition? Because the condition is checked at the end after running the loop at least once. It runs all these lines of codes at least once, and then only checks the condition, right? Right. So it's the post condition loop. While loop, for loop are called precondition loops. Post condition loop. Right. Repeat until. I think to be safe, you better write both in the exam. Right. Not really sure how Edexcel will look at this answer. A line number containing assignment statement. Assignment. Assignment.
2, 3, 4, 5.
2. Okay. Set product search to blank. Set start position to 1. Yes. 4. Set mid position to 0. Right. All these set commands are assignments, right? So they just want one, right? A line number, yeah. 3 or 4. A line number containing an operator. So operator here, they are looking at a mathematical operator. You know what are mathematical operators or arithmetic operators? Plus, minus, division, subtraction. Plus, minus, division, multiplication. Okay. Then we have relational operators. Relational operators are greater than, less than, greater than, or equal to, not equal to, so and so. Then we have logical operators, and, not, or, those are logical operators. So which one? Line number? Can you take line number 14? This increment? Not really. That is more like, I mean, that's an increment. But an arithmetic operator or a, they should have mentioned what type of operator this is, right? So something is missing there. So they have taken it as arithmetic operator. It is line number 12. So you can see these two are added together, right? So that's line number 12. A line number containing conditional statement. Yeah,
They haven't mentioned the type of operator.
that's right. That's right. That's right. But they had taken it as a mathematical operator, right? So I had to go by the mark scheme, right?
So like if we get a question like that, should we like state line numbers for each type of
No,
operator?
I'll tell you. I'll tell you. If you get a question like this, uh,
Hmm.
you better write, okay, an
Okay.
assumption, okay. As you can say,
Okay.
like assuming it's a mathematical operator, it's line number 12. Right? Assuming
Hmm.
it's a logical operator, line number this. Then of course they have to give, right?
Yes.
Just
Okay.
mention like that, right?
Okay.
A line number containing conditional statement. Conditional statement. Then there should be a check. There should be if, right? So we have line number 13. There's an if statement. In line number 16, there's a if statement. So 13 or 16. Okay, got it. Right. So we come to the last question where most of you didn't do, which you kept blank. Well, this one, mm, this one, of course, you need to understand what happens in this. You need to go through each line of code, each step. Right? And if you look closely, this is actually bubble sort. This is performing bubble sort on some names on an array data. Okay, and we have to do a dry run on this. Right now, look very closely. There are plenty of dry run examples in the book. You redo them and practice. This is a definite question. Okay, right. First of all, let's try to understand what happens here. Right, you can see there's a flag. So it's a Boolean value. Flag is 0, count equals 1. Is name count. So we have to assume that the array is already read, this array, right? So since it's a pseudocode, they have started with 1. Otherwise, we start with 0. So Jamal, Amir, Eve, Tara, right? So count is 1. Is name count. Name count means name 1. Name 1 means Jamal. If Jamal is greater than name count plus 1. So count plus 1 is 2. In the second question, we have Amir. So we're actually checking whether Jamal is greater than Amir. What does that mean? Jamal greater than Amir, right? So it's not the height or anything, right? It's not the age or anything, right? It's the name. So we are looking at the alphabetical order, right? We are looking at the ASCII value of the letter. So JA, is it true or false? Is J greater than A? Alphabetical, according to alphabetical order?
No.
No? Hey, A, B, C, D, F.
Yes.
Right.
Yes. Yes.
A, B, C, D, E, F, G, H, I, J. It is, yes, right? Because A is 65, and obviously J has to be more than that, right? If the first letter is the same, we look at the second letter. So this is true. If this is true, you need to understand what happens here. You can see name 1, that is Jamal, is put into a temporary variable. Name count plus 1, which is Amir, is put into where Jamal was. So we put Amir here, and we put, before that we put Jamal into a temporary variable. Then we put Amir into this place, and then we put what is in temp into count plus 1. That means we put Jamal, who was in the temp variable, into where Amir was. So what exactly has happened? We have swapped the two values. Amir goes here, Jamal comes here, right? So this is that famous algorithm which is known as swapping algorithm. Swapping algorithm. Okay, so if you understand, right, if you can understand that they have used the swapping algorithm here, you should remember bubble sort, because in bubble sort the main concept was swapping values, checking the order and swapping, right? So if there's a swap, you can see that flag is set to 1. Initially flag is 0, so it's the flag which keeps this going on until the whole list is sorted. Okay, then we increase the count. We need to increase the count, right? Because we need to check the other values, right? Okay, is count equals 4? If count equals 4, 1, 2, 3, 4, that means we have, if we have reached the end of the list, what do? We go and reset these values. You can see we go back. Sorry, we go back here, not reset. Okay, we go back. Sorry, if it is not 4, that means still if there are values to be checked, we go back and continue the same, right? But remember, flag will be 1 if there are stops. If we have reached the end, if the count is 4, we check whether the flag is 0, because it's a flag which will continue this whole process until the whole list is sorted, right? So if flag is 0, if flag is not 0, we go back and do the same process over and over again. Remember, in bubble sort there was something called passes, right? And one pass is going through from left to right, swapping the values if needed. That was one pass. But after one pass, we didn't get the list sorted. So what did we have to do? We had to do several passes, right? So it is this, right? Flag 0, no. It is this which controls the number of passes. Okay. And in a pass, right? In a pass, if you haven't done any swapping, that means the list is already sorted. As long as there are swaps, list is not sorted. So if you go from left to right completely uh, without any swaps, that means list is already sorted. So if flag is 0, that means there are no swaps, right? And we have gone from left to right completely, right? And still the flag is 0, which means the list is sorted. Okay. And that's when we exit the program. Understand? Did you understand or not? Yeah. Did you understand? Yes or no?
Somewhat, sir.
Somewhat. Okay, somewhat. Right. I know it's a bit difficult to understand. That's right. Because we didn't get the algorithm for bubble sort in the book, right? Now you will come across this in A level. Definitely, it's there. A much more advanced version also. But one thing is that now to answer this question, you don't need to understand it completely, right? So no need to waste a lot of time on understanding this. Just get the idea. Just get the idea what happens. The main idea that you should get is we are doing the bubble sort here, right? In this bubble sort, we are checking whether the left is greater than the right. And if left is greater than the right, we are doing a swap, which means we are arranging them in ascending order, right? So you can see here, right? If Jamal was greater than Amir, we swap the values, which means Amir came to the left, right? That means the lower value came to the left. Okay, which means it's going to be sorted in ascending order, right? So having that in mind, let's do the dry run. Okay, so don't worry if you couldn't understand the whole thing, it's okay, right? At least if you understood that we do the bubble sort here, That's more than enough. Bubble sort, and the values are going to be sorted in ascending order. That's enough. Okay, right. Now the dry run. Let's do it carefully, right? So you also must do it, right? Otherwise you won't understand. So after the class, take like 5 minutes and do it on your own. uh, Definitely you will understand it better than now, right? Okay, so what do we do in a dry run? We have to fill the current values of each variable, right? You can see flag is there, count is there, and all the values in the array. Temp value is there, right? Okay, so let's do it. So if you want, you can start with the first row, or you can start with the second row. Since they have given so many rows, we can start with the second row. Okay, so flag, what's the value of flag at the beginning? Tell me. I think others are having podcasts, no? Yeah. Till soon, ne? I'm also going to get the podcast.
0, sir.
0, yes. So let's do it together. It's going to be 0. And the count is going to be 1. Okay, now what? Here is name count is greater than name count plus 1. That means count 1 means Jamal, count plus 1 is Amir. Is Jamal greater than Amir? True or false? Is Jamal greater than Amir? Is J greater than A? It is
True.
true. If it is true, we go this way and we swap. No need to go through one by one, because we know this means swapping. Swapping means Amir comes here, Jamal goes there. Understand? I don't know. We had to fill the temp value. Hold on. Right. So we need to go through it. So we put name count, which is Jamal, into temp. That means Jamal goes into temp. Okay. And then we put name count plus 1. That is Amir into the place where Jamal is. So Amir comes here. Right. And then we put temp into count plus 1. That is, we put Jamal into the place where Amir is. So what has happened? We have swapped the two values. Okay. And Eve and Tara will be the same, will stay the same. Okay, right. So nice. I got the pocket. Nice. I got the pocket. Can you hear me?
Yes, sir.
Can you hear?
Yes, sir. We can hear you.
Can you hear me?
Yes, sir. We can hear you.
Can you hear me? Can you hear me? Okay, yes, right. So since we are recording, we'll complete this, right? Okay. So that's after that we are here, right? We are here. Now the flag is set to 1. So we need to update the flag. Flag is set to 1 here. We close this window. Okay? Right. So flag is set to 1. And then what? Count is incremented by 1. So the count becomes 2 here. Understand? Is that clear? Binuki, Vishal? Vishal, Binuki, can you hear me? Can you hear me? Abhasana, you can hear me, no?
Yes, sir, I can hear you.
I can hear you. Speakers. Speaker. Okay, anyway, looks like something wrong, but I will, since it's recording, I will explain, right? Okay, can you put a text message if you can hear? If you can hear, can you put a text message? All right, great. So now the count is 2. What do we do? Count is 2. Count is count equals 4? No. So we go back and now we check name count against name count plus 1, right? So name count is name 2. Name 2. Name 2 is Jamal. Right now in name 2 we have Jamal. And name 2 will be compared with name 2 plus 1. That is name 3. So we will be comparing these two, 2 and 3, right? So name 2 greater than name 3. Name 2 we have Jamal, we have name 3 Eve. Jamal greater than Eve, that is true. So what we do is we put name count is name 2 into temperature. That means Jamal, not temperature, temp, right? Jamal goes to temp again, right? And then what happens is what is on the right, that is name 3 goes to name 2, that is Eve goes here. Okay, and then we put what is in temp into name count plus 1, that is name 3. So we put Jamal here. The rest won't change. Amir and Tara. Easy, right? And then flag is set to 1 again because there was a swap, and we increase the count by 1, so the count becomes 3. Okay, this time is count equals 4? No, so we go back and check count against count plus 1. Count is 3, count plus 1 is 4. So this time we are checking Jamal and Tara, right? Is Jamal greater than Tara? No, right? It's no. Jamal is not greater than Tara. So we go this way and we increase the count. So the count is incremented by 1, so count becomes 4, and there's no change to the list. Am I right? There's no change to the list, right? Jamal and Tara.
Yes,
Yeah,
sir.
so it's the same list. Amir, Eve, Jamal, Tara. In the temp, we still have Jamal because we didn't reset the temp. Right? Flag is still 1 because it didn't change. Count was incremented. Earlier flag wasn't changed. Now is count 4? Count is 4, right? Count is 4. And then we check is flag 0. Right? You can see flag is not 0. If flag is not 0, we go back and we reset the flag and the count. Okay, so now flag becomes 0 and the count becomes 1. Okay, so this is 1 pass, right? This was 1 pass. We went from left to right completely, and now we are going to do the second pass, right? So here also there's no change. Amir, Eve, Jamal, Tara, Jamal. Understand? Right. Now let's do the second pass. Is name count greater than name count plus 1? Count is 1. Count plus 1 is 2. So we are checking Amir and Eve. Amir and Eve. and it's in the correct order. Amir is not greater than Eve, so we go this way and we increase the count. So no swap. So the count becomes 2, and the flag still stays the same, 0. Okay. Is count 4? No. So we go back and now count equal count greater than count plus 1. Count is 2. Count plus 1 is 3. So we check 2 against 3. 2 against 3. Eve and Jamal, right? Eve and Jamal, it's in the correct order. So no swap. We go this way. Count is incremented by 1, becomes 3. Flag is still 0, right? This time count equals 4. No. Go back. Count greater than count plus 1. Count is 3. In 3 we have Jamal, and 3 will be checked against 4. Is 3 greater than 4, or is Jamal greater than Tara? No. So it goes this way, and count is incremented by 1. So count becomes 4. Flag is still 0, right? Right. Is count equals 4? Yes. Is flag equals 0? That's also yes. And that's where we end, right? When it is ending, there's no change to the list. So the same list will be here: Amir, Eve, Jamal, Tara, and the temperature was not replaced. So the temperature, sorry, again temperature, temp was not replaced. So it will be Jamal. Okay, until this, all in all these situations it will be the same. So you can just put it like this. If there's no change, you can put like this. It's the same, or you can even put the dash, right? So this is the second pass. Pass 2. Right. Did you understand? Is that clear? Easy, right? Darshana, Vishal?
Yes, sir.
Did you
Understood.
understand? Easy, right?
Yes, sir.
Okay. So make sure that you do it again. That's very, very important, right? At least do it like 2 times, right? Then you will get hold of this dry run, right? Almost all of you didn't do this. That means there must have been a problem, right? You don't really need to understand what happens. You don't need to understand the whole code 100%. But 2 important things that you should understand. That is, what they have done is bubble sort. In bubble sort, we have passes, right? We compare values and we do the swap. Second thing you should understand is that we are sorting here in ascending order. How do you know that? Right? Because we are checking the left value against the right value. We are checking whether the left value is greater than the right value, right? If the left value is greater than the right value, then we do the swap. That means we take the smaller value to the left. If you take the smaller value to the left, that's going to be in ascending order. Simple, right? And the rest is nothing, because you just need to follow the flowchart and fill the state of all these variables. Okay, at the end you can see the list is sorted in ascending order: Amir, Eve, Jamal, Tara. Right. Okay, then we have finished the paper. I will send you the code. I did the code for this, right? Let me see whether I have it. You can try the code also, and then you will understand it more clearly.